Hi gang. As I was looking back over the notes that I had written in class today, a couple things I just wanted to follow up on. So this is slide number 10. So you want to go back and find that. Just clarifying the question, will this over or underestimate? We had answered this because we cheated, quote unquote, and used our calculator to see if it was an underestimate. But you won't have the luxury of using a calculator, so we need to be able to check it based on the concavity. So we want to check the concavity of this first. And so looking at f prime of x, we'll have 8x to the third plus 4. And then looking at f double prime of x, we'll have 24x squared. Now that second derivative is always going to be positive no matter what I plug in. When I plug in negative 0.9 into the second derivative, and I've got 24 times negative 0.9 quantity squared, that's going to turn that whole thing positive. So since f double prime of negative 0.9 is greater than 0, the curve f of x will be concave up at that point. And so therefore, since it's curving up, it's a concave up section, the L of negative 0.9 that's on the linear line will underestimate, will be less than the actual value on the curve, because the concavity has pulled the curve up and away. So you're always going to base your rationalization, your reason, based on what kind of concavity the function has, okay? Not based on whether you checked your calculator and the actual value, what it turned out to be. You won't have the luxury of having your calculator, so you'll need to have a reason that's based on the second derivative. Okay, now go ahead to slide 12, and I was looking at what I wrote, and I missed a number, and so that made our problem turn out nonsensical. It happened right at the beginning when I wrote the estimation for pi halves, and I put 1.7. It's 1.57. I just missed the 5. And so then that had implications down at the end when we got to our linearization. So our linearization was negative 1 times x minus pi halves. And we were finding the linearization for 1.75. So that would be negative 1 times 1.75 minus the estimation for pi halves, which is 1.57. And so now our estimation turns out to be 0.18. So we're looking at negative 0.18 as our estimation for the linearization. All right, and then we had the fact that the concavity of cosine at that point is concave up. Therefore, the linearization should underestimate. So L of 1.75 should underestimate cosine of 1.75. So it should be too low, and it is by just a little bit. If we do then have the luxury of checking our calculators, we would see that those two things, that one was lower than the other. Okay, now we're ready to move on. Now let's talk about Leibniz. Remember that Leibniz had slightly different notation. So if f of x equals y as a differentiable function, then f prime in his notation would have been dy over dx. Now these pieces, dy over dx, he referred to them as what we would call differentials. And he saw them as independent pieces of each other, which could be, whoops, typo, moved around independently from one another. And so think about if you took the expression f prime of x equals dy over dx, and if you put a 1 under that, you could cross multiply that expression, and you would end up with dy equals f prime of x times dx as just a cross multiplication. Now that format is really helpful in what his work in terms of approximating and estimating different values. So a differential represents a teeny tiny change in that variable. So if you change one variable, it will have a corresponding impact on the other variable, but to what degree? How much will it change it? Okay, if I change my water intake every day, how will that change my overall health or blood pressure or weight? Or okay, if you make a change in one area, it would have a result in the other. If I change my chocolate intake, how will that affect my weight and by how much? Okay, one way or the other. If my chocolate intake is changed increasingly during this Christmas season, then my weight, my overall health will be changed as well. All right, so let's talk about changing something on a circle and how that will have a resulting impact. So we're going to change the radius of a circle, and how will that impact the area? So Leibniz would start with his area formula, which is the pi r squared. Okay, then take the derivative dA over dr. Okay, that's the derivative respecting to the r variable. That would be 2 pi r. And because there's implied parentheses around this r, we have the chain rule, which would be dr over itself, dr, which we know is 1. So we'll take care of that. And then we cross multiply, and we have the expression dA equals 2 pi r times dr. Now dr represents a tiny change in the radius. And then dA would represent the resulting change in the area. So it won't tell you what the area will be, it'll just tell you how much it will change. So dA in this case is 2 pi, r is 5, and dr represents how much we're changing it by. So it's not 5.1, but it's the change or the difference between that. So that would be 0.1. So then we multiply those together. So we'll have 10 pi times 0.1, which is just pi. So what that means is that if you change the radius of the circle by 1/10 of a meter, then the area will change by a total or an approximation of pi square meters. Okay, so think about that. The tiny change of 0.1 leads to a resulting change of 3.14. It's not corresponding. It's not like a 0.1 change in one results in an equivalent 0.1 change in the other. Changing the radius by a little bit affects the overall area by a total of pi. That doesn't mean the area is pi. That means the area is changed by pi or increased by pi. So find the differential of dy here and evaluate it for the given values of x and y. All right, so dy dx is 5x to the 4th plus 2. And when we cross multiply, then we can maybe just write that as 5x to the 4th plus 2 times dx. So if our x value is 1, and we're changing our x value by 1/100th, so 0.01, what will the resulting change in y be? So that would be 5 times 1 to the 4th plus 2 times 0.01. So that's 7 times 0.01, or 0.07. So dx being 0.01, the interpretation is increasing x by 1/100th, and then dy will be results in y increasing by 7/100ths. Now, again, just want to clarify, that doesn't mean that the value of y is 7/100ths. It means the value of y will be changed by 7/100ths. Okay, will this be a situation of over or underestimation? Concavity still applies here. So we want to find the second derivative, which would be 20x to the third. And in this situation, when x is 1, I get a positive concavity. Positive concavity leads to the differential being an underestimation. Okay, we could just always think about the positiveness is pulling the curve higher than what your estimate would be. And so this would be an underestimating situation. All right, so that covers Leibniz, and you have it compared to Newton. So you'll just have the two contrasting methods and then being asked about over and underestimating. Okay, I look forward to maybe seeing you on Friday, and if not, I will see you next week. Have a good weekend.